Hello class. So today we went over how to import, export, and work with our AutoCAD files in other different and separate programs. So one of the most foremost things that you want to be able to make sure is that your AutoCAD drawings or drawings that you're trying to export out is lying within the proper XY coordinates, because AutoCAD works within sort of an infinite range of space and other programs do not. You have to make sure that your drawings or the portion of the drawings that you would like to export and work with in other programs are within the maximum limit of where it can be shown. And in order for you to do that, its best way is to make sure that your drawings are within the 0, 0 coordinate of your XY UCS or Universal Coordinate System. So by some chance, if your drawings are like way off here, and again, if you have many drawings because it's a big project, you should have drawings all over the place, in which case make sure the portion of the drawings that you would like to work within the work with the other software lie within the preferably within the center portion of the XY coordinates. So in this case, we have a kind of a very small portion of drawings, and it's quite easy to put that into the center. So we're going to use the move tool, and then we're going to lock that corner all the way up to the 0, 0. Now you can use the snap to grid to snap it perfectly nice into the XY coordinate if you like. And this is ready to go in terms of exporting up to the Illustrator and Rhino. So to do that, make sure that only the portion that you're working with in AutoCAD to other programs are in your drawings. If you have any other drawings or like some reference lines or other stuff that you are not bringing in, make sure you delete those and save a different file versions for that file, so you preserve the original version with everything in it and new version with just the stuff that you're going to export out. So here it is. So I'm going to save this as drawing file. I'm going to name this as AutoCAD to Rhino Illustrator Export DWG, and then make sure that it's on 2000 version of the AutoCAD, not 2018, 10, 13, or 7, but 2000. I'm going to save this. Now this is ready to be opened or imported into the Rhino. So here we have a Rhino open. So the first thing you want to check in Rhino is, as you've done for the AutoCAD, is that the unit system the Rhino using is exactly the same as the unit system that's being used by the AutoCAD. This way there's a consistent scale among different programs. So to do that, you can obviously just type in units, just like the way you do in AutoCAD, and then this pops up. Right now, by default, Rhino, because it's a metric system and it's actually an international program, set to a metric system. So we would like for this to be working within the inches instead of the millimeters. So I'm going to pick inches. Now this has a proper unit system that allows us to bring in AutoCAD with the unit system that we have used, so that there is a seamless transition of two programs sharing the same file or same drawings. So here it goes. So to import our AutoCAD drawings into the Rhino, you want to go to File, you go to Import, you're going to go find our AutoCAD file, which was this guy. So I know in your video it says import unreferenced layers, import unreferenced blocks, import line types was unchecked, and they're absolutely right. The reason why I had this on when I was importing my drawings from AutoCAD is simply because I do not have unreferenced layers, block, or line types. But yes, you should absolutely uncheck these items when you do import your drawings from AutoCAD. So your model units and layout units should match, so make sure they're both in inches, and then say OK. And here you have it, your AutoCAD the drawings that you were looking at from the AutoCAD section. So of course we have to also make sure that the units are indeed proper and correct. So I'm going to type in distance. Now I've already said it before that Rhino also has a OSNAP setting, which is critical when you're making drawings in Rhino. So the OSNAP setting is down here by the menu on the bottom. It's off by default, so you should turn it on by clicking on it, and it will highlight it for you. And once you click on it, of course, just like the AutoCAD, it's got these different snap settings that you should turn on for your convenience. So in Rhino, you should always, almost always, have end, point, mid, perpendicular, and of course vertex on. Once that's on, we can use the OSnap to measure our walls. So 302 inches, which is equivalent to about 25 feet, and 2 inches, which is proper. Now, as I said before, here you can convert this into a feet and inches instead. But as I said, even though the measurement may not be in feet and inches, it's probably perfectly fine for you to be able to simply use this file, because after all, the scale is not off. It just simply uses a different unit system. And as I said, there is an option for you to change it to feet and inches. But again, that causes a little bit more of a complexity that you may or may not want to deal with. So let's leave it as is. So once our drawings are properly imported, we are ready to convert this into a 3D model so that we can do some preliminary diagram production for your two-dimensional representation. So here it goes. First thing we're going to do is, I think last time our block was sort of getting in the way, so we're going to just simply click on our blocks. That includes our furniture too. And then let's add this into a different layer, or excuse me, move it to a different layer so we have a clean sets of line that we need for us to start making 3D. So once those items are selected, it's as usual, you want to simply shift click and select all the items. And then we have a layer tab similar to the AutoCAD layers on this particular tab called layers. It has a little cake icon on it. And then let's put those layers, pardon me, let's put that block into a separate layer and we hide them so we never have to kind of deal with it again. So I'm going to create a new layer. To create a new layer in Rhino, you're going to have a little icon called a new layer. It's a little paper looking icon. If you click on that, it creates a new layer for you. So to utilize layer or move items into a layer or new layer, all you have to do is right click that layer and then simply say change object layer. You should do this only after you have the object that you would like to move into that layer selected. So we already have the blocks that we would like to move into that layer selected, so what we have to do is right click, change object layer. Once that has happened, those items are now in that layer. See, if I hide and unhide the items, it disappears. And you can also, of course, assign colors, which corresponds to the line colors of the drawings. So once that's added, let's hide that and let's call that a blocks. I'm sorry, furniture and finish. And we hide it. Now that we have a nice clean line for us to be able to extrude our drawings, we can begin. Let me just delete that one. Can begin. So first things first, in Rhino, navigation is quite easy. If you would like to pan, as you can see, I'm on the top view, which is equivalent to the AutoCAD view of the XY coordinates. If you would like to pan your view, all you have to do is go to right click your mouse and drag for you to be able to pan around your modeling environment. You can also zoom in and zoom out by using your scroll button. Now, before we start making this into 3D items, you want to be able to be in the right view for 3D, so top view is not. So if you want to change the view, all you have to do is double click this little tab where it says top, and then our 4 separate view appears. This, your perspective view, is your default 3D views. And of course there's a right view and front view. The other 3 orthographic views. So let's go to the perspective or 3D view by double clicking on the tab, the view tab. So the reason why we also brought in the elevation drawing is that the elevation drawings will give us all the height information that's necessary for us to make this into a 3D model. And height information is necessary for us in terms of making a 2D plan into 3D, because they will tell us how to extrude or make it into a 3D solids, or how far or how tall or how high to make the 3D model. So for us to do that, let's also make sure that our elevation is in the right orientation, so it's much more convenient visible view of, so that we can use that height information. And for us to do that, it should also be flipped upwards and upright, so that we can see the height information in proper angle. So let's do that. To rotate, to rotate our model or our drawings, it's similar to the rotate command you find in AutoCAD. There's a rotate command that you can use. Before that, let's also talk about the navigation in the 3D view. Unlike the top view, in order for you to be able to pan in 3D view and perspective, you have to use not just the right click, but shift and right click. Shift key, hold that down, and right click, hold down, and then move. Because if you just simply use the right click, it will not pan, instead it will tumble or simply rotate in three-dimensional space when you are on the perspective or 3D view of the Rhino. So that's an important distinction to remember. When you're on the top view, let's go back, double click. To pan, it's just simply right click and drag. You don't have to press the shift key. However, if you want to pan in the perspective or 3D view, double click it. You have to be able to right click and shift. There you go. So now we're ready to flip or rotate our elevation view, so it will be in the proper orientation to use its information. So first, before you rotate, you want to select your object first, and then use the rotate command. Now, although this is a good view for our 3D view, it is not a good view to rotate a two-dimensional object. So let's go back to our two-dimensional orthographic view. So let's double click again. It's still selected, and let's choose the right view this time. So we know that this is the beginning of the rotation, and this is the end of the rotation, where we want to be able to flip the object upwards. So make sure your object's still selected and type rotate. So this is the center of the rotation, and this is the reference point where we want the rotation to move up and down. So let's click at the end point, and then it can move up and down. That's how we can rotate object. Now we can do this in many different ways. One of the ways is if we just simply have the ortho lock on, it'll automatically go to the 90-degree perfect rotation. Or simply, if you don't have that on, you can also type in the degrees that you want to rotate to. So type 90, it moves up. So there you have it, our elevations in the right view. So we're going to make 3 separate primary components to make in 3D. Number 1, it's our floor. Number 2, it's our wall. And number 2, it's our 3, it's our ceiling. So let's first create our floor level, which is this guy. So before we can create our floor level, right now we technically do not have our floor level here. What we do have is our walls, but not our floors. So let's first draw our floors, so that we can draw our floors in 2D, so we can create a 3D version of the floors. So to draw in Rhino, it's actually quite no different than in AutoCAD. There's these various drawing tools, including a polyline, regular line, circle, and so forth. So to draw a floor, which is a perfect rectangular, let's choose the rectangle draw tool. Just like in AutoCAD, it's left click to start, right click and drag, and where you want to finish the drawing. So let's left click here to start at one point of the angle, one point of the rectangle, and then right click, not right click, drag to end here where we want the floor dimension to be. So again, left click here, drag, and left click once again to let go and finish that dimension. Now I know it looks like we didn't do anything and our lines disappear, but it's there, it's just that it's overlapping against another line, and Rhino will tell us that. So if I click on the edge where I thought I put the rectangle in, and there you have it, it tells you that it's on this particular curve. and that's our ground level. So what we're going to do is we're going to extrude or make a ground level 3D and tall enough to fit this height. Now we don't know what this height is yet. Now we can measure them by typing in distance. Because we have our O snap on, it should the snap nicely. So snap here, it tells us it's 11.5. Now we can go with that and use that information to extrude our ground level. But instead, let's try a couple of things. Our first way first, which is we use our snap setting to literally snap against this line, which is the edge of that floor. So to make two-dimensional lines or two-dimensional objects into 3D, one of the first and most easiest command and option to use is this thing called extrude command. Extrude command converts a closed two-dimensional line that includes circles or blocks or rectangles, closed two-dimensional shape into a 3D by extruding its line work into a three-dimensional space, or simply z-axis. So to do that, we're first going to click on the items that we want to extrude. Oh, excuse me, we said that we're going to start with the floor first. So click on the floor, which is this one. Let's extrude it, once again, using OSnap, lock it up against this line. So we're going to extrude curve. Extrude curve is the command name. As you can see, it's moving up and down. The first thing foremost we want to do is make sure that we want to be able to make sure that our 3D object is solid. So it's solid no by default, which means that it's not going to be 3D. It's going to be three-dimensional plane instead of 3D. So if this was no, which is by default, and if we do that, right now this doesn't really kind of tell us anything. In order for us to show the 3D view properly, you also want to make sure that your view, you can tap in the view option by clicking on the triangle on the view tab, and it's wireframe by default. If you click on shaded, it'll give you a proper 3D view. As you can see, we had the solid equals no as our option, and therefore it's not a solid object, it's really a three-dimensional plane. But we want a solid object. So let's do that one more time, but this time let's make sure that our solid equals no is yes. So once again, click on the ground plane, extrude curve. We're going to click on solid equals yes by simply clicking on that option. Simply left click it, now it turns to yes. So now it's asking you to extrude up or down, making the 3D object upwards and downwards. So we want our ground plane to come up all the way down here. So just like our polar tracking on AutoCAD, it actually does that. It locks into various key points. So as you can see, it follows your command. So we want to be able to lock it right there. And then there you have it. Our floor perfectly aligned with our elevation drawing. So if you want to double check, then all you have to do is just simply look at the front view and it matches up. Now, one problem that this has created is that our floor plan 3D drawing is still below our floorboards because we extruded upwards. So in order for us to properly see our floor plan, because we need that for us to extrude the rest of the elements like walls and partitions, we need our ground level to be below our floor plan 2D drawings. So to do that, we're going to learn our next command, which is called the move tool. Now, move tool in Rhino acts exactly the same as AutoCAD move tool. If you type in move or simply M, it's going to ask you what objects to move. I want to move the floor object. Press enter, and it's asking you to where to move from. Now we want to move this corner of the floor to move down below where the floor plan is, so we can see the floor plan. So let's do that. I'm going to click on that part where I want to move off of. I'm going to move it down. Again, use that tracking. It locks up right there. Now that is where it is below, directly below our floor plan. That's where it's want to be. I'm going to click it. Now our floor, three-dimensional floor is below our floor plan. We can still see our floor plan. Now that's the next thing we want to do is we want to be able to still use our elevation drawings, but unfortunately, because we moved the floor below, right now it's our elevation drawings and our floor plan doesn't match. So we have to rematch it. So the best way to do that is just simply that we have our floor plan sync exactly next to our two-dimensional elevation. So to do that, we're going to simply line up our floor to the floor line of a 3D object to the floor line of a 2D object, so that they're exactly against each other, and therefore when we extrude object, we have our direct reference right next to it. Easy convenience. So in other words, let's move our two-dimensional floor and our floor plan and match it against our two-dimensional elevations. Let's do that. So once again, move tool, select the object, and this time everything within the floor. Press enter to say yes. Point to move from. So I want to be able to move this point to that point. And just locks up right there. Now, everything we create from now on, from from wall to the ceilings, will be precisely match our geometry. Precisely match our drawings. So our next step, which is the wall, which is directly above the floor. So let's do that. Same as we did with the floors, to make it into a 3D and using extrude command, you have to first select the geometry. Now if you notice, there's a lot of overlapping lines here, and Rhino allows you to see through the overlapping geometry, but allowing you to have a choice for which of the overlapping drawings for you to be able to choose. Now we currently have our wall selected, but we also want to extrude our floor plan. Something's gone wrong here. I'm supposed to have a little partition right there, but let's do this first. Let's extrude our walls so that it meets the ceiling end of our elevation. So I'm going to press extrude again. And once again, because our O snap is on, it should lock up right where it's supposed to be, which is right below the ceiling. There you go. Now let's go find out what happened to my wireframe. Looks like I kind of forgot my partitions while I was bringing some stuff over. So many of your drawings should have a partition there, so I apologize if that's not showing up. Let me see if I can just render that. Hold on a moment. So, but let's first at least extrude the partition that we did bring in. So I'm going to extrude this. Same thing, I'm going to lock up against the walls. Once again, there should be a partition there, but let's skip that for now. Now this is pretty much ready to go, except we only have one thing to finish, which is the ceiling portion. Just like the floor, ceiling has exactly the same dimensional criteria. It covers the entire ceiling same way as the floor covers the entire area. So we can create a new ceiling by scratch, or simply copy and paste. I press copy. Copying and pasting is the same in Rhino as any other software. It's Control-C to copy and Control-V to paste. So I've already Control-C'd it, and then let's Control-V it to copy and paste another floor geometry. Control-V to paste. Now, according to what we're looking at, it doesn't seem like there's anything new there, but it really is, which is simply that the floors are overlapping one again. The duplicate of floors is overlapping together. In fact, if I click on one of the floors, see, it tells you there's two extrusions. So let's select one, and let's use the move tool to move it up against the beginning of the ceiling line. Again, so the beginning of the floor line against the beginning of the ceiling line. Again, we're only moving one of the duplicates. And then it should lock up nicely right there. See, the other original or simply a duplicate is still there. Now we do have an issue that it's slightly bigger than the original elevation height. Now we didn't do this in class, but maybe this is a good chance for us to learn another tool, which is a scale tool. Now we only use scale tool in AutoCAD on two-dimensional drawings only. So here in Rhino, it's quite easy to scale things in 3D view of a three-dimensional object quite easily. Command is pretty much similar, except it gives you a more variety of options and easy to use features. So all we want to do is able to just simply shrink the height of this new floor, shrink the height of this new ceiling to the original ceiling elevation line. So which means that we don't have to scale this in proportionally, which in 3 dimension it's going to get bigger as it goes higher. We want to be able to control our scale command so that it's enforced or restricted to just merely lowering and increasing the height. So to do that, there's a handy scale tool called Scale 1D. So type in Scale 1D. After you have selected your object that you're trying to scale, type Scale 1D. Scale 1D. It's going to ask you for origin point. Scale 1D is almost equivalent to the scale exercise that we did in class. You first select the origin point, and then next you're going to select the endpoint that you're trying to control. See that? The endpoint you're trying to control. And then it allows you to move that up and down and downwards. Now in AutoCAD, you have to also press R button or reference point in addition to that before you can get to this point. But in Rhino, you don't have to. So again, now I can move this up and down and control the height exactly the way we want it. And let's lock up exactly where it is, where it's supposed to be. So I know that might not have been very clear even though you're watching this video. So let me try that one more time. Once again, scale command is the scale 1D. So don't just type in scale. There's a separate scale command called scale, which scales in 3 dimension or proportional 3 dimension. You don't want to use that. Use scale 1D, please. Now I know I had objects selected before I use scale 2, but you can also do it afterwards, just like you're doing in AutoCAD. But let's do it the way we did before. First, select the object you're trying to scale. Type in scale 1D. Point of origins here, and then we're trying to lower this point to here. Again, point of origins here, and we're trying to lower this guy to here. So let's click the point of origin. Oh, sorry, wrong. Click the point of origin, and then let's click on that guy to bring it to down there. So once again, let's try it one more time. Select the object, type scale 1D, point of origins here, and then we want to bring that guy to down here. So click point of origin. Next is asking for the first reference point, which is this guy. And then of course allows you to bring it up and down. So we now have ceilings, and we have floors, and we have our window, walls, and partitions. So this is almost ready to make it into a 3D render. But before that, let's organize our drawings the way we've always organized our AutoCAD. Let's get rid of our 2-dimensional lines right now, because they're sort of distracting. So it's easy for us to select all the lines in Rhino. There's a command called SELCRV, or simply select curve. Allows you to select all the curves or simply lines or polylines in your Rhino. Once it's selected, it's indicated by with yellow. We're going to put this into a new layer. Again, go to click new layer, and the new layer was created. Our lines are still selected. So let's bring all the lines into our new layer. So line selected, new layer selected. Do not click off anywhere. So if you did that, the lines are still no longer selected. So be very careful when you're doing this exercise. Make sure that if you are selecting object before you do something on, make sure it's still selected. If you select any other things on screen by accident, you'll unselect your stuff. So once again, CRCRB, and then only right-click here on the layers that you wanted to move your drawings to. I'm going to say change object layer. That's how you bring in stuff that you selected into the new layer. Change object layer. Now that it's been moved there, we can double check by clicking on and off, and there you have it. All our curves are there. Let's rename this curves. Let's also hide it and lock it. Now that this is almost ready to go. So a diagram is about systematic and precise control and view and representation of your 3D model and your 3D designs. It relies on continuous and consistent render and portrayal of your model, so that it always comes out consistently when you when you export it, when you save your renders, because consistency shows gradual changes and to your drawings and your project. So therefore, it is a good way for you to be able to use it as a diagram to explain the rationality for your design, which is sort of one of the most fundamental things that you normally learn in design schools for architecture and interior design. So in Rhino, it does have a very convenient controlled view called the isometric. Isometric is equivalent to axonometric, except that axonometric has a slightly more 45 restricted views. Again, your teacher should not give you a hard time, because isometric view, which Rhino does have by default, isn't exactly axonometric view, which is a skewered or unrealistic view of a three-dimensional plane. So isometric should be fine. And because Rhino has it by default, it's quite easy to use and convenient. So let's make sure, before we get to that isometric view, make sure you have your model that you're trying to render into a 3D portrait selected entirely. Make sure it's selected entirely. And then I want you to go to the triangle arrow on the View tab. Go to Set View. Go to Isometric View, and then click on Northeast. Notice after you've done that, your model has been centered nice and easy into the center. And then of course we have our isometric view, which is a slightly less restricted view of axonometric. So obviously we want to be able to consistently draw all of the series of diagrams in the exact same view. So we don't want to really lose a view or distort the view when we produce multiple renders of the same view, but using different components or different parts of your model and geometry, which is what we're going to do. So in order to do that, we don't want to worry about losing this view. So it just so happens that Rhino has a good way to bookmark your views, So to bookmark your views, there's a command called name view. A name view tab should pop up if it isn't already up there already. So it's right here. But if it wasn't already up there, it should pop up like this. If you want to put it back in there, all you have to do is just drag the tab, pop up. Right now, this view has not been bookmarked. To bookmark your view, make sure your name view is opened, and then there's a saved as icon. Click on it and let's call this diagram A. Now that view has been bookmarked, this perfectly nice and center view is bookmarked, and all we have to do is, if we want to work anywhere else, pan, just by mistake or intentionally, you lost your view, but you want to go back there, all you have to do is click on diagram A again. And it's very important that you know that this is where you want to be when you are ready to render, because everything else you add or subtract before has to be in that exact same identical view for that exact same identical series of diagrams. So now that we have our views nicely saved, it's ready to go. Next step is, of course, set up our view array. So let me close this first. If your view array option, the one that the tab that I just closed, isn't available or seen in front of you, then simply turn them on. To turn that on, all you have to do is go to the render option of the file menu. Go to the current render, and then make sure view array for Rhino is clicked on. Rhino for render is probably on by default, but make sure this one is on. Now, because I shut down the tabs, it disappeared, but it's just as easy to bring it back again. Go to the V-Ray tab, and then click on Asset Editor, and then it just brings it right back. So we are going to make two basic objects with two basic objects, or two basic types of object, two basic material types in V-Ray with series of different colors. So this is your V-Ray asset editor. Pretty much everything that goes on in V-Ray goes in here. The interface is quite simple. So here we have our material list where our new material, or AKA the way how V-Ray renders objects in V-Ray, in Rhino. That is the material, or explanation for what material is. And it goes here, the list of materials that you create or bring in. So for this exercise, we're going to create a two basic material called generic. And then we're also going to create a material called tune. First of all, let's rename this. Let's rename the generic. Right click. Let's call this white base. Right click. Let's call this white base. And let's call the tune. Right click. Let's call this white diagram. And you'll get to find out why I'm naming it like this later. So tune is a very special type of shader in V-Ray Rhino. It has a distinct outline to its material, whereas the regular white base generic material is just simply a solid geometry. So if we combine both, your render will not only have a solid part, it will also have an outline part, same way that we've been drawing all of our AutoCAD drawings. It's got an outline. So, in order for us to combine the two, what we're going to do is we're going to go back to our tune shader, which is now called the white diagram. And since we already have a white base, again, I'm going to tell you why that's necessary in a second. Under the parameter of the white diagram or tune shader, there is a parameter called base material. Under the base material, right now nothing is assigned, that's why I say it's none. Click on it, and then it will reveal white base as a possible option. And if you click on that, as you can see, our tune shader, which is formerly just simply a round object with outlines on it, it's changed its looks. It's got an outline like the way the original tune shader is. It's also got a solid part similar to our base part or base material. So what that does is basically tune shader now includes the base material as part of the material's design. So which means if we click on the base material and change the color by changing the diffuse, this is your diffuse. Click on the box, and if I change that color to white, as you can see, well, yes, the base color changed because it changed to white. However, if you look at the white diagram, it also changed because our base diagram changed. Now, some of you guys might be thinking, well, the color says it's black in here, but that color doesn't correspond to the solid 3D geometry. It's only responding to the outline of this material, and that outline of this material is black. So in fact, if you also change those material, see, outline of that material hasn't changed. Please keep it to black for this initial range. So what we have now is two different type of render material called tune and generic. What we're going to ultimately assign to this will be series of these two, but with different colors. Let's create our first render because we have enough to create our first render. Let's first select our object. That's the first step to applying your material in V-Ray to your Rhino model. Select it, and then right-click the material that you would like to assign. Right-click the material you would like to assign. I would like to assign white base to this material, so I'm going to right-click the white base. And then there's an option called Apply Material to Selection, so select that. and it has been applied. Now, right now it doesn't look like anything's been done to your model, so per usual you have to slightly change your view so that it gives you the preview of the material that you're applying in V-Ray. So I'm going to go back to the View tab, click on that little right triangle, and right now it's set to shaded. If you click on the render mode, it changes to the material of the V-Ray. So to check that this is indeed the V-Ray material that we assign, all you have to do is just simply make some changes to its parameters, and as there you have it, it is changing. Let's go back to white. So at the moment, I only wanted to put white base render material to this model. I didn't want the outline along with it for this round, so I didn't apply the white diagram. I only applied the white base. Now this is almost ready to go. Now we have to do some couple initial steps in V-Ray settings for you to be able to properly render this. So your V-Ray settings are listed under the settings options, which looks like an asterisk. If you click on that, this menu pops up. Only two things you have to memorize for this particular setup, and that's all you need for this rest of the semester, and that is your quality set to from medium to very high, and then your global illumination, make sure it's on by default. And then if you expand that menu, there's an option called the ambient occlusion. You also have to have this one turned on. And that's all. Those two guys. Well, this technically if you want to kill that, but this is on by default. And that's all you need. Now the next thing is, of course, there's a thing called render output, which renders the size of your render based on what is set on this image and width height. For now, let's leave this as is. But you know where it is, just in case next time you want to make a smaller render or a larger render, you just simply type in the size that you would like. There are various set standard size to make the renders. Please seek those guides. Now this is ready to go. Now to actually render, you always want to make sure two things. Number one, am I in my diagram view? Remember now, systematic and controlled and consistent view is how you do a perfectly good diagram render for your presentations. And right now I'm not. My diagram A was perfectly centered isometric view. Right now this is not. Now to go back to that, because we bookmarked it, all you have to do is double click on the area where you bookmarked it on your name views, which is this guy, it's called diagram A, and double click, and it goes right back there. Now after you've done this, please don't start clicking through and do this once more and we have to go back there. The idea is you go back here once and when you're ready to render. So yes, now it's finally ready to render. To render, you can click on this button called Render with V-Ray. This window is called the V-Ray frame buffer, by the way. So when it finishes, it should tell you. If you would like to know when it finishes, all you have to do is click on the Render V-Frame Buffer. Here it is. So there you have it, 100%, it's finished. That's my first diagrammatic render, which is basically a white base model. Some people call it plate model, but it's really ambient occlusion, which has a little bit of depth, a little bit of shadow, which is all you need to show commonly known as a massing model diagram, or just simply a massing model. Now the render is finished, all you have to do is just simply save. There's a save little icon here. Let's call this diagram A. Now I should really call this a mass model, but I think in the entire tutorial it's a diagram A, so let's just call it diagram A. And save file type is portable graphics, so don't use any other types unless you know what you're doing. Save. Because I had previously other things, it's asked me to resave it, so I'm just going to say yes. Let's close some of these. And you don't have to close the V-Ray asset editor. Let's minimize it. What we're going to do is we're going to create a series of additional setup on my model for me to be able to get the rest of the diagrams ready for render. So to do that, instead of trying to alter our current model, it's much easier for us to just simply duplicate this model and then work with the duplicate instead of messing up our original model of the diagram A render. So let's duplicate this model. So to duplicate it, as we did before with the floor, it's copy and paste. But because this one's a little bit more complicated, we want to be very careful about a copy and paste feature. So let's have our layers activated first. By the way, in our tutorial, we had our extensive looking layer names. This is because I unclicked or unchecked all those unreferenced layers. So Pasma, I hope I'm pronouncing that correctly. Yes, you're absolutely right. It's much better for you to be able to uncheck the unreferenced layer and all those checkboxes that you learn from the video. So do it this way. I've only sent this video to you because it's really available, but again, obviously I have my own way of doing it. However, yes, it is much more preferable to have those items unchecked before you do the import, and that's why we have a nice, cleaner layer profile. And back to what we were doing before, we want to duplicate this so we can create a series of more diagram features from the same model, but without having to ruin this one particular diagram model for that one particular diagram render. So we have to duplicate it. So we first want to select the object to duplicate. Again, be very delicate and slow about this, because when you copy and paste object in Rhino, it places it exactly identical and same place as where it was before. So it's going to be very difficult for you to extrapolate out if you do not follow this step quickly and for the first time. So do it very carefully when you do it. So make sure select all your 3D geometry because we want the duplicate of everything. It looks like it's completely selected. I want you to copy, Control C, and then I want you to paste, Control V. Now again, it looks like it did nothing, but it really did paste it onto this exact area. Do not, under any circumstances, start clicking your mouse. If you do that, you're going to lose the selection. So to differentiate our duplicate model from original model, I want you to go to the Layer tab. I want you to go to the New Layer to create a new layer from your layer. Let's call this Diagram B. And then right-click that Diagram B and then say Change Object Layer. The new duplicate object, or simply it could be the original model, has been gone to the Diagram B layer. To double check that, I'm going to hide the Diagram B layer. As you can see, something happened here, right? And then what we also want to do is make sure that our original model, or simply a duplicate model, again, I'm not sure which one it put into the Diagram B, but that part really doesn't matter. I want to be able to put our original model into a separate layer, in its own separate layer, so that we can differentiate the both precisely. So select your model, your entire model once again, create a new layer. Let's call this Diagram A. And then right-click again, Change Object Layer. Once again, make sure you are not unselecting this object. And then let's hide it. As you can see, because there was only one object in the Diagram A layer, everything disappears. To make sure this duplicate exercise worked, click on Diagram B, it appears. Click on Diagram A, it appears. Now to make sure that, to distinguish both, you should also give a layer color. Right now Diagram B is red, Diagram A is green. Now even though my layer color has changed, my model hasn't changed. It's because right now my model is showing the way it's supposed to render, because we are on rendered view. To see it from the layer color view, all I do is just switch back to the shaded color. And there you have it. It's switched to shaded color view. Layer color view. If we hide the Diagram A, which is in green, and unhide the Diagram B, which is in red, as you can see, it has been assigned to its own layer color. So we're doing diagram B, so let's only select and view diagram B layer. Now these other layers should be nothing in it, so let's also hide those. So from here we want to be able to do the next additional sets of diagram. Again, these diagrams are, by the way, one of the most fundamental things or diagrams you do for almost just about every type of design and architecture exercise there is. It's also commonly used at work and professional environments. So very easy at the same time, very fundamental to learn and use. So the next series of diagram we're going to use is basically called a component diagram, where we show each individual components of the buildings as a separate component. So those components are, in this particular model, it's roof, floor, walls, and partitions. So we're going to render those components separately using different color base as our render material. Sorry, I wasn't supposed to render that. Let's go back to our this is called the materials button, and if you click on that, your material will be revealed. So we want each of those components to be a separate color so they can be distinguished as a separate object. So let's do this. Let's create a series of different color base for those series of different color components. Now we can create a brand new one by doing this. Go to generic. We can simply duplicate the white base because it's pretty much the same thing except using different color. So to make a duplicate of the material, instead of copying and paste, there's a right click and there's a duplicate option when you right click. So do this 2 more times because we need 2 more colors. And for each of the duplicate white base, let's change the color. I'm only going to stick to the primary colors for now. So let's properly name our base. Let's call this color base 1. Do not leave the white base as is. Color base 2. And color base 3. Now we can start using this obviously, but for the next series of diagram, the component diagram, let's use the Toon Shader version. So we has this one. So it has an outline along with its solid white colors. Solid colors. So unfortunately, we only have one Toon shader with one base color. So just like we did the additional 3 color base, we also need a 3 additional Toon material so that it has its own separate color base material. So let's also duplicate this layer. 1, 2, 3. Now, before we start assigning the proper color, let's also rename this. Let's call this color diagram 1. Color diagram 2. Color diagram 3. Now once again, the diagrams are different from the base. Base has no contour lines, right? Because they're not Toon Shader. Toon Shader, on the other hand, has combination of both. But before it has the combination of both, remember what we did with the white diagram? We had to assign the white base, right? So we're going to do that too. We're going to assign a color base to our other color diagram Toon Shaders. So let's do that. Color diagram 1, And let's change it to color base 1. Color diagram 2. Let's change that to color base 2. And last but not least, color diagram 3, color base 3. So now we have 4 separate sets of tune shader called color diagram 1, 2, and 3 and white diagram. Now we are ready to assign these diagram tune shader to our components in our building. So let's apply to our ceiling first. That will be the color diagram 1. Let's just go through it 1, 2, 3. To see the preview of the render, of course, you have to go back to your render view. So our roof is red, or color diagram 1. Now let's do our walls. Now there's a grouping command similar to that in AutoCAD and Adobe Illustrator. We haven't got Illustrator yet, or Photoshop. That allows you to group objects together so you can select them as one instead of individually, like we just did just now. So to group objects, make sure you have your object that you would like to group selected, which is my walls, and then simply type or keyboard shortcut Control G, not Z, G, and then it groups your items for you. So for my walls, which is now grouped, let's assign diagram 2. Now we have one more, which is our interior partition, but right now it's slightly not so visible. So to do that, we need to sort of temporarily hide our ceilings for convenience. If you look up here on the standard tab, which is by default tab, there's many menu items icons. I want you to look at and find the light bulb icon. Do not click anything yet, just find it. Once you found it, there's also these triangle buttons below it showing you that there's additional menus below. So for this particular run, I want you to use this button, which is called hide object, and then it hides your ceiling temporarily for you, so that reveals a partition. So I'm going to select my partition. Yes, I know I have my middle absent for some reason. Yours should have one. Select your partition and let's assign that color diagram 3 as material. Now that we have all of our components nicely applied diagram material into it, which is a tune shader, we need our roof back. So to return our roof, we're going to go back to our light bulb command. Instead, this time click on the on light bulb, which is simply show object, and then our roof is back again. So to render these series of component diagram renders, instead of rendering the whole thing, we're going to render them one component at a time. By the way, we're going to keep the ceiling and roof as one component. And as before, we're also going to make sure that all of our renders only in diagram A view. Same thing before. If it's anything else, like if you're on any other views, make sure you're on double click diagram A view. It kind of reminds me of Circus tent for some reason. In fact, it does look like Circus tent. I think this is a clown. It's a primary clown color. That wasn't intentional. You guys are designers. Pick appropriate colors for yourself. So we want to be able to only render ceiling at a time, walls at a time, and partitions at a time. So to do that, we're going to start using more advanced feature of this hide and show object command, which is our light bulb up here. Let's do the first thing. Let's do our ceiling and floor first. To do that, first, select your ceiling and floor first. And then go back up here. Do not click on that button yet. Click on the down arrow, and then select inverse selection and hide object. Once again, do not click on this hide object. Click on the down arrow, select inverse selection and hide object. Anytime you want to return to where you were before because you made a mistake, you clicked on the wrong thing, just simply click Control Z. Rhino pretty much remembers every step and everything that you've done up until that keystroke. So there you have it. We only have our roof and ceiling open. Now this is ready to render. Now we're not going to render just yet, right? Because we're going to systematically control and be consistent with all of our view, which is our diagram A view. Now this is ready to render. So let's render this. Where's my render option? Which is this. Here we go. And to render, we're going to click on this little called Render with V-Ray. And that's done. Let's save this. Let's call this roof ceiling. Turn all this off again. Now we need to have the rest of our models back. So same thing. We're going to say show object. This time we want to render the walls next. So select the walls. Mine's grouped so that we don't have to select everything or all the other components one at a time. Let's just select walls. Same thing, do not click on the hide object, click on down arrow, select invert selection and hide object. We're not going to render this, we're going to render in diagram A again, systematic, controlled, consistent view, and then let's render this. My render option has disappeared, so I'm going to go back and V-Ray, render option, and then render. If you don't see the render progress bar, it's probably because it's underneath your windows. If you have a dual monitor option, just simply drag this into another screen. Now let's save this as walls. I already have these things set up, so last but not least, let's do the partitions. Once again, show objects. I'm going to select the partitions. I should also group this. I'm going to press Ctrl G to group our partitions. I'm going to do it one more time. Select object. I'm going to do it one more time. Go back to diagram A view. And then last but not least, render. Let's call this partition. I know we didn't do this in class, but let's also render everything together. Click on show object. Yeah, let's render this whole thing together. I'm going to click on name view, diagram A again to make sure that we are consistent with our views. And let's render this. Yeah, it looks like a clown tent. Please don't use these primary colors on your own home project or studio project. And there you have it. I'm going to save this. Let's call this complete model. Now we did the axonometric trick for our class renders. So this tutorial video is 1 hour far, and I'm kind of tempted to not to move along, but you know what? You guys are one of my best students, my favorite students, so I'm just going to keep pushing on and make the entire video for you. So let's do that. So I'm going to go, so to do the exploded axonometric view, which is where we see components coming apart, up and down, so that we can see all the components separately on a single view. Once again, exploded axonometric diagram is seeing all the components separately in a single view. It's called exploded because it looks like it's exploding apart or upwards. So to do that, only thing we need to do is just simply separate the object and distancing them from one another. Now, Just like we did with the diagram A, we don't want to ruin this particular setup of the diagram series B. So let's duplicate this and then make a diagram C layer and then start our new exported axonometric render from there. So let's go to the layers, select everything, same thing as we did before, control, copy and paste exercise. Be very careful selecting and unselecting here while you're doing your layer add options here. So once again, select your model, control C, copy, control V, paste it. Do not click on here. Go to new layer, type in diagram C. Do not click on it. Right click, change object layer. And then it has now moved, or your duplicate objects has now moved to diagram C layer. So let's hide that. And let's also hide the diagram B layer to make sure that it has gone, by the way, just like AutoCAD, there's a selected or working layer, and there's other layers indicated by the checkbox. Unlike AutoCAD, it's not as finicky. So by default, you should always, to have a workaround this, always should have your default layer as your current layer. And then if we also hide the B layer, just simply hide the B layer. So we now have three separate sets of object in diagram B and A layer. So this is where we want to start to do some changing here. So make sure you're on diagram C. So again, export axos, all we have to do is distancing some of the components and then rendering them in a view where we can see all of it. So let's do that. Let's first distance our roof from the wall. So let's do this not from the perspective view, but let's. Sorry, I had to draw back up this particular Windows trick. If I minimize my window in any ways, it will shut off the recording. So anyway, here's continuing on. So all I did was minimize so that we can maximize our right view. Remember that we have our three orthographic view and one 3D view. So all I did was go to the right view. So from here, we just want to simply distance our ceilings a bit from our wall. And we have that. Next, let's select our walls. Now, your first basic instinct is probably selected this way, but if we do that, then we're also going to select the partitions. So make sure you only select the walls. Go back to the right view. Select also the ceiling, shift click, and move both up simultaneously. Now, you don't have to do it simultaneously. If you want, you can just simply move this up and arrange this separately. If you want, you can do that. But make sure you have a ample room about this height, and make sure they are equal in distance from each other. Equal in distance from each other. Again, there's an accurate way of doing this. Obviously, I can draw a same line, about 10 feet of space between these two to have it precisely accurate. You can do that. In fact, I recommend you. Not necessarily 10 feet, but having the exact distances using the line as its reference. But for now, to make it quick, just kind of eyeball it and have a good distance between. So we have distance between the wall and the partition, and the wall and the ceiling. Next, of course, let's also have a distance between the floor and the partition. So let's bring that out again, about the same amount of space as this. And I think this is ready to go. Let's go back to our perspective view. Now, I said consistently always go back to diagram A, but here's a problem. Our diagram A doesn't fit all of our object in our model space now, and it's supposed to be. After all, we have more stuff, not more stuff. We have the same model, but they're complete distance from each other, taking up more space. Therefore, we need a more space to include into our diagram, into our render view. Obviously, one thing that we do not want to do is we want to keep consistency, but without having to sacrifice the view, right? So this view, if you recall, came from isometric northeast view. So if you click on that, it is still isometric northeast view, same as our diagram A view, except this time it includes all of the components that we need to render for this particular render, which is exploded axle. So I want you to do that. I want you to go back to your set view, go to isometric northeast. Everything is nice and clear and visible. Actually, I want the partition to come down a little bit more because it looks like it looks slightly tucked underneath. Let me do that. So once more, I'm going to go back here. I'm going to bring down my diagram walls a bit, more downwards. Again, I'm just being finicky, so you don't have to do this if you don't want to. Yeah, I'm being a super finicky. Again, you don't have to. I actually kind of like the way it was before now. So this is ready to render. Now before you do that, just like we did with the diagram A, we want to go to save this view so we can always return to it just in case we make a mistake by moving around and so forth, right? So let's do that. Let's go back, first go back to our default view, our safe zone. And let's save this view. Let's call this diagram, I think it's C, diagram C. So now we can always move around again and then go back to diagram C. Remember now, diagram A is not the same as diagram C, right? This one is used for single model, and this one used for exploded model. Now it's ready. Now let's render. There you have it. This is ready to go. I'm going to save this as an exploded axle. And that's it. That concludes the diagram render portion of this exercise. So next step is we're going to bring this guy, or not this particular model, bringing our model into the Illustrator environment so we can do further dressing work in Adobe Illustrator program. So just like we did before, we want to be able to preserve this and then have another layer that we want to be able to use to make our, or excuse me, set up our files intended to go to the Illustrator. So let's do that. So right now, this is already in diagram C, so we don't have to do anything. However, we do want a very particular looking a model view of our survey plan, which is we want to be able to see this view without the ceiling so that it reviews essentially a three-dimensional floor plan view, right? So which means it just simply diagram A without the roof. So let's do that. So I'm going to click on the roof. So we can do this thing. If we're doing this smart and you've been following along and doing this consistently, what we want to do is we want to have a duplicate, right? So let's do that. Select everything from diagram A, copy, paste. Do not click on click, click new. Let's name this. You know, since we're not making a new diagram, let's name this export to Illustrator. And then right click, change object layer. So there you have it. I have one whole new one for export to Illustrator, and we have our original diagram A preserved. So for the one that we want for export to Illustrator, we don't want the roof, so let's just delete that. Now this is ready to go into Illustrator. Now we're not going to bring in 3D object to Illustrator. We want the line work from 3D object to Illustrator. And as I said before many times, consistency and systematic view that we export and preserve for diagramming and drawing exercises. So which means that we also want this view without the roof also be on our previous name view, which is our diagram A view. Not the C. Again, C includes everything, right? No, we want the diagram A view. This is now ready to be transferred into a line drawings that AutoCAD Illustrator can open. So to convert this into a line drawing, select your model, your entire model. Do not click and undo these, because if you do, you're going to lose your original view. So once again, go back to your view, select your entire model, and type in Make 2D. There are many different options for today's tutorial. Make sure current view is on, and everything else set to default, and say OK. Do not click and then click anything here just yet. I want you to go to the top view, and I want you to, again, do not click anything just here yet. If you did that, but if you did click on something by accident, simply undo and redo the Make 2D exercise again, because it's going to be a little bit harder for you. What you want to do next is, after you go into the top view, you want to group your line drawings so they're not in pieces when you're selecting them. So once again, Control G, and then you have lines that have been grouped together so they can be selected easily. So if you go back to your layers, we have some new layers here called Make 2D layer. Rhino makes this by default. I mean, obviously we can use this layer because everything just goes in there, but we don't want to do that. Let's go back to default as a current layer. We want to be consistent, so let's make this, let's select our lines, just the lines. By the way, my export to 2D layer is on, right? That's why it's on, so I'll make sure this is also hidden. Hide your export to 2D, export to Illustrator layer. We'll only see the line drawings. Let's also create a new layer called Export. Let's call this Export Line. And let's add our new line drawings into that Export Line Drawings, so that it's in that layer. And let's get rid of the Make 2D layer because it's a bit confusing, it's a bit convoluted, and we don't need it. So everything is in perfect order. So we have our export to 2D line, and this is ready to go into the Illustrator because our line works. So from here, you don't necessarily have to be on the name view like we did before, because this captures this name view. So you don't have to be on the name view for you to do the next, which is exporting into Illustrator. So select your object first, in this case, which is your line drawings. Go to File, go to Export Selected, and then let's call this Diagram Line Export. And then from the Save As File type, make sure you choose Illustrator as your file type. Now we're not done yet. You're going to click on Options. Snap to Current View is on by default. Make sure your Preserve Model Scale is on. And if you recalled, we've been making our survey plan in 1/4 inch, it goes to 1 feet. So inch, 1/4 inch, it goes 1 feet, which is 12 inch. So once again, 1/4 inch, it goes 1 feet, which is also equals to 12 inch. So this is 1/4 inch, it goes 1 feet. 12 inch, it goes 1 feet, and 1/4 inch is 1/4 inch. So this is ready to go and matching the scale that we have specified for our previous drawings of our survey plan. And then we're going to say OK. And then we're going to say Save, and it's going to ask you the same thing again. We're going to say OK. Now that this has been saved as a your line drawing saved as the Illustrator file, let's save this file since we're done with Rhino for today. Let's call this So when you open Illustrator for the first time, it should look like this. We'll go over more details in Illustrator next week. But for now, if you open Illustrator, either you should have some kind of a white backboard here on your screen and your interface open like this here. If you don't, simply go to the File, go to New, accept whatever this gives you by default. It's extremely large paper size. Again, don't worry about it. We'll go over how to change those in next class. So we'll just say create, and then same thing. It gives you the white canvas. So we're now ready to open the Illustrator file. Now, the reason why I had to open Illustrator first before we open the Illustrator file is because my recording software will shut down if I ever minimize Windows. So that's the only reason why I have the Illustrator opened before opening my Illustrator file that I have saved from the Rhino. But it's not necessary. You can simply directly open the Illustrator file without having Illustrator open before. So keep that in mind. So I'm going to go to File. I'm going to go open my currently saved Illustrator file from Rhino, which is this guy. No, wait, it's actually here. Diagram. The diagram D? No, it's this thing, sorry. Line export. Yes, that is the correct one. And there you have it. Our line drawings perfectly imported into the Illustrator. So we're going to go over what we're going to do here in Illustrator portion next week. But for now, Illustrator opens entirely new possibility in terms of what we can do to our drawings. This was our original file, some poche work, some line work, some texture works. You get some basic ideas, and the idea is that it gives us much more expressive control over how solids and line works are controlled. It also gives us more expressive control over how we make patterns and how line works, and just for that matter, just about anything visual can look like. Whereas AutoCAD was extremely restrictive and mechanical in terms of how things look, other than drawing your plan, obviously. But in Illustrator, it gives you much more expressive, much more organic control over what you do with it, and that's the sort of the beauty of what this particular tool allows you to do. So that's what we're going to go over next week in class. What we do with our drawings once it gets out of AutoCAD to Rhino and Rhino to Illustrator. Or if you prefer, from AutoCAD to SketchUp and SketchUp to Illustrator. So there you go. That's quite a